we have Codeforces div 1, div 2. So this is rated for me. And good luck if you're doing it. I'm probably going to be doing my work on paper. Probably just the ones with like the ones ending in 9. That's it. So it's just +1 over 10. Zero, one, wait, that doesn't look right. Never mind. I don't know why I said that. Okay. Oh yeah, I dropped a purple. So hopefully I can get back to orange soon. Okay, nice. Wait, what? When do you move it right? After placing the chip, you move it to the right several times. After moving, okay. If S is ABCDEF, you place the chip onto the third character. I'm so confused. Oh, okay. So you just see whether it's possible. How many people have solved this? What? Okay, that looks boring. Wait, can you just... test every character? So test this one, go forward, go backwards. Wait, so when do you stop going forward? shoot. It's like a bunch of A's, you don't know where to stop. Or maybe you match, so you loop through every pair and then you match those two and check if that works. Yeah, that was slow. Wait, I read in N, right? No. Okay, so I and J are matched, so wait, they're only matched if their characters are equal. Okay, so you check everything below J. Okay. And then we have to check the other side. v dot char at k equals not a dot char at I minus k minus j. Just trying to optimize this so it won't TLE. Because it's 500 cubes, I think. Why is this dead code? What? Wait, this one's supposed to be no. Okay, these two are equal, then I don't get why this is dead code. Let me debug here so it will stop when it works. I is 1, J is 2. Wait, what? I is 1, J is 2. How does that even work? Oh, I'm stupid. I knew there was something fishy about that. Let's hope this doesn't TLE. That took way too long. 10 should be good. First team this. Okay. Based on your predictions, minimum possible kicks there can be in... Wait, what? Oh. Okay, no predictions. Okay. Okay, there are only 10 characters. Can we just binary search? Yeah, we can binary search. Or we don't even need to binary search. You just loop through. So can it end here? Alright. Should be pretty easy. So if it works, so that means if like the one count on the even indices Wait, will this run in time? Ten times 10 times 1,000. Yeah. Kmod 2 equals 0. Okay, so how much do you need for it? You need a win by okay, if 0 is gonna win, then 0 wins plus 0q. If 0 is gonna win, then 0 leading by okay. So then is there a way 1 can come back? If k mod 2 is 1, then lead minus minus. If lead is greater than 0, turn true. Okay. This should work. Wait, what are we printing? What? 9? How's that 9? J is 6, I need to investigate. Okay, 0 wins is 2. Okay. 1 wins is 0. 0q is 1. 1q is 3. So now if 0 wins, wait, how is it even 7? I should have looked at the sample. First, 5th, and the 7th. Wait. I'm stupid. 11? This better work. I'm very slow today. Backspace B, C, backspace D. Your task, if you type the string S and press backspace, instead of typing several characters, to charge my computer. Wait, I mean, if they're like the same characters, then obviously it's possible. Okay, so you can essentially start anywhere. You can start anywhere, and then so many string questions. Something backspace. Something. Okay, so you can just remove even length substrings. Start anywhere and remove even length substrings. So how do we implement that? A. Then we need to find a B. Find the first B that's even length away. And the first A that's even length away. Oh, that's it, yeah. Okay. Wait. Okay. So find the first A that's even length. Let's just do verdict of index less than 0. Yeah, okay. I should have left that in. Let's hope this passes, because that would be a fast D. But the speed of the first three matter much more. Oh, it looks like E and F. Wait, how are we doing in the standings? Okay, we're doing pretty good. Wait, is E or F easier? E looks easier. Find all possible values of K. Okay, so first, wait, what is the point of that? Why would they do that? Oh, okay. So if it's a 1, it's 4, 1, 2, 3. Wait, can k be 0? Yeah. Let's just write down all the permutations. Or the cyclic permutations. 1, 2, 3, 4, 1, 2, 3, 4. Okay, that makes sense. So the number of possible values of k, and then the values of k. See, a swap can be like, I don't know, a swap can just change a lot of things. Okay, it's reachable within m swaps if they're less than or equal to m plus 1 positions out of place. So there has to be less than or equal to 1 position out of place here. Wait, m is less than or equal to n over 3. Does that mean, wait, why would they make it n over 3? Does that mean a randomized solution? So when is this in place? Wait, so we just calculate how far each of them are away. So this is 2 away. 1 is 2 away. 2 is 1 away. 3 is... Wait, what? Okay. 1 is 2 away. 2 is 3 away. 3 is 3 away. And 4 is 0 away. So in that case, if you shifted 3, So we just need to find the values that are greater than or equal to m plus 1. The values that have frequency. So you need at least m plus 1. No, you need at most m plus 1 positions out of place. So at least n minus m minus 1 positions in place. So anyone that has frequency. Is that not easy? That feels really easy, but I'll just code it, I guess. Maybe I'll realize what's wrong later. So we add that position. And then we print all the answers. I doubt this will work because that seems way too easy for an E. Wait, hold up. Why is that wrong? One? How does one work? If a distance of 1, Wait, what? So 2 is 2 away. Zero, 1, 2. What? So 1's position is 3. So 1 minus 3. How is that right? I'm so confused. 1, 2, 3, 4. Okay, 2 is 3, fine. 3. Oh. Oh my god. Oh, I'm stupid. Two, 3, 3, 0. Okay, and n minus m minus 1. What? Why am I trolling? Bro, this makes no sense. Should I just submit this? I probably misread the problem. Okay, last elements of the original array. confused. Are a lot of people missing this or something? At most m times. Oh my god. I'm stupid. Oh, so it can be even less than m+1 operations to fix it. Okay, well that should be useful. Okay. The minimum it can be is n/2 operations. Or like the number of this empty ones over 2. It's just n minus the number of cycles. m+1 minus, wait. If there are wait. If there are k positions out of place, then it takes k minus the number of cycles to fix it. Okay, so how do we find the number of cycles? So you shift these by 3. So then 1 will be -1 away, and 4 will be, so then 1 will be 3 away, and 4 will be -3 away, so 1 away. Why didn't they include one of those in the sample? Okay, but this array should be helpful. So if they both have to, okay. So 1 needs to be shifted by 2. 1 needs to be shifted by 2. How do you tell how many cycles there are in the rest? Okay, if 1 needs to be shifted by -1, then you find what's in 4's place. So where does 4 need to go? Wait, so 1 is here and 4 is here. After shifting by 3, 1 is here and 4 is here. Wait, what? 1 is... Oh, after shifting by 3. Here and 4 is here. After shifting by 3, 1 is here and 4 is here. So 1 needs to move back 1. 4 needs to move forward 1. Oh, this is actually math. Okay, I'll try E for a little longer. So after they're shifted by 3, four needs to move forward 1. Okay, wait, the n over 3 thing has to be something. Randomized, maybe? So less than or equal to m over. Okay, so we know there has to be at least that many, or at least what? Oh my god, I'm stupid. That's what the n over 3 is for. Has to be at least 2n over 3. So let's say m equals n over 3. So if there are 2n over 3 positions out of place, so less than or equal to 2n over 3 positions out of place, it's greater than or equal to n over 3 positions in place. Okay, and there are finitely many of those. So you just test all of those. Yeah, you test all of those. Alright. I'm stupid. So that's how many are in place. Okay, sweet. Okay, so now I just have to create the worst method. Okay, so J is how much you shift it by. Yeah, J is how much you shift it by. So where does the 1 start? 1 starts at J plus 1. Rk equals k minus j. And then Rk equals R okay, so then how many so then we need to do BFS. Cycles plus plus, okay. So then while BFS is not empty, so how do you get the child? So that represents that. Oh my god, I can't think right now. So this is R, this is dist. Okay, so you add index 3. And then where's 3 supposed to go? Okay, wherever 3 is supposed to go. Wherever the thing at index 3 is supposed to go. what is dist? What? Dist is how much it has to shift. Dist represents how much that number has to shift. Okay, so dist dot length minus plus 1. No. Dist dot length scene dot size minus the number of cycles. So that's how many swaps it takes. Okay, this should technically work, but I'm bad at coding, so wait, is R not right? R of dist dot length wait, what? How? Wait, I'm stupid. taking way longer than it should. Okay, hold up. Why is this weird? Index out of bounds exceptions of 4. Let me test these cases one by one. Plus, so this actually almost works. Okay, that's why. God damn. Hold up. Oh, I'm stupid. I've probably said that like so many times. Okay, so we have array. Wait. This is desired. Should probably use the input. Oh. Hold up, this is still working. I mean, it's not working. So we need this to get to the input. less than or equal. Bro, I ran through it way too fast. This is gonna be so much slower than it should have been. Wait, what is scene? Oh, I didn't even do scene.add k. This has gotta work. If this doesn't, I know this is the right solution. I'm just being stupid. Okay, this should work. Why is this giving index out of bounds? Because I have to change this to k. Just not outputting anything. Wait, why is it just not outputting anything? Oh. I can't type. What is this? Okay, K++. This is so bad. What? Why is this working again? Is less than 0. That is... So... I hate debugging this. Like, if this doesn't work, I might just move to F. Wait, this shouldn't even be that hard. I'm just really bad at implementing. Okay, maybe I should just re-implement this. Because this is a stupid way of implementing it. Okay, shouldn't even be that hard. Okay, that's the input array. And then the array we want it to change to. I'll keep this part. Okay, so we want to turn input into array. So, what does 1 correspond to? First we need which positions. Okay, so then adjacent of Wait, is that not... That's it. I'm just stupid. Yeah, that's it. Okay. We need this to be less than or equal to m. What? Yeah, it has to show up at least n over 3. Yeah, that's how many it takes to... Wait, I didn't try. I should try my own cases. If it's greater than or equal to n over 3, then you need to try it. Yeah. So you try it. Okay, I'm really confused. Maybe I should just go ahead and try F. The sum of AI mod AJ. So how much is like AI mod AJ counted? Okay, maybe I can't get that. E is not hard. I'm not sure what I'm doing. 2, 3. 1, 2, 3. 1, 2, 3. I have no idea why this could be wrong. Okay, what? Wait, I'm actually stupid. Oh my god. Well, I guess it happens. Okay, wait. I think we can try to get F. Yeah, G seems weird. Okay. So the first one's obviously 0. The second one, okay, that's 2. So maybe if we sum over AJ, okay. So how many times does AI mod AJ get added? Wait, no, never mind. The sum of everything mod AJ. maybe we start out with just the sum of everything, and then we subtract all the mods. So everything that's less than, okay, so for 2, everything that's less than 2. Everything that's less than 2. Nothing is less than 2. Oh, no, okay. So you start at the largest number. Okay, so everything mod 7. So you subtract the ones. Then the second largest number, everything mod 6. This is hard. Yeah, I don't really have an idea. All AIs distinct. Okay, so you loop through for a j. Okay, so let's say you're looping for 2, then 6, 2, 7, 3. So you add 6 mod 2 to this, 7 mod 2 to that. This is n squared. Are there any hacks? Oh, what? There are a lot? There are a lot on B. There are a ton on B. Maybe I should lock mine. Yeah, I don't think I'm gonna get F. C equals C. No, C equals C or DFS of x00. Wait, this is wrong. Yeah, this is wrong. This is wrong. I can't copy and paste into, but I'm pretty sure this is wrong. Wait, let me open the problem again. Print yes if it's possible, no if it's not. SB AAA AB. No, SC. SC AAAC. Wait, that's it, right? SCAAB and S. I'm so bad at hacking. I should probably stop hacking, but no, yeah, that's good. This looks really sketch. If ST is -1, then break. Okay, wait. No, this can't be right. What is F? F is 0, then F is 1. We set F to be 1. Then if F S S T No, what happened? Oh no, this guy's gonna hack it before me. If F equals 1, so first he's checking for backwards. Oh, F represents whether we're going forwards or we're going backwards. Wait, no. This is really confusing. You know what? Just try and hack. Is it actually not tested in the samples? think this should work. Shoot. Did I forget a space at the end? I think I forgot a space at the end. Successful. I think that's my first ever hack on Codeforces. Okay, wait, how much time is left? 5 minutes? Bro, this is way too long. No, this is right. I doubt higher rated people will... Yeah, this is right. Wait, how much is a hack? Oh, so I got plus 50. Solution has been hacked or resubmitted. Wait, what does that mean? Don't know what that means, but who was I hacking? No, it was not this guy. Who was it? Oh, the thing I was trying to hack got hacked. I think. At least I think that's what happened. Two minutes. Don't want to rush it. Yeah, these ones that loop over the starting and the length are right. I'm pretty sure. It's just shooter shot at super high rated people. Yeah. Okay, at least we gain rating. E was a complete disaster. Wow. Okay, I guess time for solutions. I'll do solutions for A through E. Okay. Problem A. Digit sum. Oh, this one. Okay. So an integer x is interesting if the sum of the digits of x plus 1 is less than the sum of the digits of x. Okay, so let's say the last digit is not 9. So if the last digit is not 9, the last digit of x. So let's say these are the digits. A1, A2, A3, A4, A5. If the last digit is not 9, then this is just A1, x plus 1 is just A1, A2, A3, A4, A5 plus 1, because that's also a digit. So then the sum of the digits of x plus 1 would be greater than the sum of the digits of x. So that means that none of, like, the only possible values of x happen when the last digit is 9. So what happens if the last digit is 9 is this digit becomes 0, this 1 is carried over, and that's basically it. So this, the sum of the new sum of the digits of this is definitely going to be less than this if the last digit is 9, because the zeros keep getting, like, if A4 is 9, then this also becomes 0. If A3 is 9, this also becomes 0. And then eventually this one becomes like A2 plus 1. And this 1 is not going to be enough to make up for all of this. You can just try examples, but if the last digit of x is 9, then it works. So then we can just come up with this simple formula, n plus 1 over 10. So that is our answer. The number of x between 1 and n that satisfy this. Okay, problem B. Now this one, I hacked someone at the end. So yeah, you have to be careful about something. So we have a string S and a string T. Let's use, let's use the example that I hacked someone on. So let's say this is string S and this is string T. You want to start at some index and keep walking forward and then keep walking back and then stop at some ending index. And all the characters that you hit in order should form this. So for example, to get this, you would start at S, then go to C, then go to A, then go to A, and then stop at this A and come backwards. So then come back to this A, and then come back to this C, and stop here. So the characters we visited are S, C, A, C. So basically, maybe like one idea that doesn't work is you loop through all the starting indices and keep going greedily until these two characters are not equal. So this method actually doesn't work in this case, because you can see it actually, after this A, it actually goes to this A, because these two are equal. And then it tries to go backwards here. But since this A is not equal to that C, then we have a failure. This A is not equal to that C. So then that algorithm will not work. So instead we can, since the size is less than or equal to 500, we can loop through all starting indices and the length. So let's say it starts at I and the length is J. So then you can just brute force check if you start at I and the length is J. So you go J steps forward, and then you keep coming back until you reach the length of T. So yeah, you just basically brute force over these, and the runtime will be like 500 cubed at max, but it'll be less if you break when it's not possible, or simple like things like that. It's less than 500 cubed, so it should run in time. But yeah, you loop over the starting index and the length of the string. I'm sure there should be other solutions, but that's probably the one that's most intuitive. I might have solved it a different way. I honestly forgot. Okay. So problem C. Oh yeah, penalty. I guess this problem was okay. So we want to find the earliest possible place you can stop, so that it's essentially like not possible to come back from. So what we can do for this, let's just take this as an example. 1 question mark 0 question mark question mark. Okay. So team 1 and team 2. We want to find the earliest possible place you can exit such that it's possible for the mercy rule to come into effect. Basically, it's not possible to come back. So what we can do is just loop through, starting at the first index, just loop through until we find a spot that works, and then we just print that. So to tell if like some spot I, if it's possible, So what we can do is find the number of wins that team 1 has. So this is just the number of ones that are in even positions, even index positions. So let's say that's like 1 wins. And find the number of question marks in even index positions. So these are 1 question marks. And then do the same thing for team 2. So it would be the same thing except at odd indices. So 2 wins and 2 question marks. So to check if the mercy rule applies, I don't know why I'm calling it that, but yeah. So let's check if team 1 wins by the mercy rule. So to maximize team 1's lead, we want to set all the Q's over here to be 1 and all the Q's over here to be 0. So then team 1 wins would be 1 wins plus 1 Q's minus 2 wins. So then the mercy rule applies if for the rest of these from I+1 to the end, it's not possible to come back. So we can set all the question marks, or actually we have to remember that the referee does not take into account predictions when deciding when to stop. So what that means is we don't know these yet, these numbers, when we're at I. So instead, to tell if the mercy rule applies, we set everything at odd indices to be, everything at even indices to be 1, and everything at odd indices to be 0 in the rest, because we're not allowed to see those predictions. So this is the current lead to I, and then if it's not possible to come back, then we want to make sure that if all of if all of team 1's scores are 0 from I+1 on, and all of teams 2's scores are 1 from I+1 on, if all that happens, then team 1 still wins. So essentially the lead subtracts by the number of odd indices after I. So if this lead is greater than 0, then it's possible. It's possible, so we just return at I. And we also have to do the same thing for team 2. So if 2 wins plus 2 question marks minus 1 wins. Remember, if we want to maximize team 2's lead, we set all the 2 question marks to 1 and then subtract and set all the 1 question marks to 0. So this is team's 2 lead, then minus the number of even indices after I, because these will be all of team 1's wins. And we ignore these because we're not allowed to see the predictions. So if either of these 2 numbers are greater than 0, then we stop. And we can just like brute force calculate this. The size of the string is only 10, so it's not that bad. So yeah, that's problem C. So now problem D. Oh yeah, another string problem with S and T. Okay. Okay, so backspace. We have a string S. A, B, A, B, A. Okay, and then we have a string T. B, A. So in place of every time we type something, we can either type the character or type backspace. So if we type like backspace B, backspace B, A, then this B would go away because this A is a backspace, and we're just left with BA. So yeah, something to notice at first, I guess, is that you can remove from string S, you can remove any prefix. So we want to get from string S to string T using some of these operations. So the first thing to notice is we can remove any prefix. And the way we do that is we just press backspace for that prefix, and that removes it. And then, so for the rest of the string, we can either type a character or type backspace. So let's say we type A and then we type backspace. This A goes away and this B is not there. So every time we type backspace, we can think of it as essentially removing its character and removing the character previously. Because removing its character because it's not included in itself. You already have the lack of typing that character, and in addition to that, you backspace the previous most character. So every time you press backspace after some prefix, then you can think of it as two characters are removed. So I guess if you play around with this more, you realize that from S, you can get to any string that has some prefix removed and other substrings of even length that are removed. So like if the string was longer, D, A, D, so let's say some prefix removed, A, B, A is removed, and then we can have substrings of length, even length removed. So like we can have AC removed, AD removed, or we can have ACDA removed, and we're just left with the things that are left. So how do we calculate that? That seems a bit complicated. And the hard part of this is dealing with the prefix, because we would sort of have to loop through the prefix and then try and remove other stuff that are even length. So that's going to be hard. But if we think of the string in reverse order, then it'll actually be easier. So let's say we start out with let's say S is A, B, A, B, A, T is B, A. Or let's change this a little. T is CA. So if we start at the end of S, we can do this kind of greedy algorithm. So these two are equal, so that's good. We move on to this. You know what, let's change this to C. So now the pointer is at this index and the pointer is at this index. So these two are not equal. So we shift this by 1. These two are equal. However, the thing in between the last index that we took and the current one is odd length. So we cannot take this index. So we move on. Turns out this is also C, but however, we have 2 now, 2 that are removed. And since that is even, then we can take this. And then since we're at the end, that works. So this greedy algorithm works. I guess a way to see why like it definitely works is that, of course, if you take some character previously that works, there's no way that can affect a later character you take, because that character will always still be there. So yeah, this greedy algorithm works, and that's basically it. So now problem E. Okay, problem E. Yeah, I was just it's not gonna be that hard to explain. I was just really dumb with my implementation. So we have an array, and we first cyclically shift it and then have to perform at most m operations, and we want to see which cyclic shifts, or is it possible to do m swaps and get the resulting array. So let's use the first sample, just 2, 3, 1, 4. So the cyclic shifts are 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 3, 4, 1, 2, 3, 4. So these are the cyclic shifts. So one thing to notice is that, let's say there are k positions out of place. Then we need, if there are k positions out of place, then we need a maximum of k minus 1 swaps to fix it. And you can see that by just every swap you put some index in its correct position, and then the last index automatically will be in its correct position, so you don't have to do the last swap. So you need at most k minus 1 swaps. So I guess it's better to look at it the other way. So let's say you have k swaps. What is the maximum number of things that you can put out of place? So let's say you have like an array in its correct order, and you want to do k swaps to put the maximum number of things out of place. So that would just be k plus 1. That's just looking at this the same way, except in reverse. So you have k swaps, and then the not the maximum, I misspoke earlier, but the minimum number of things that are out of place using k swaps is k plus 1. Wait, no, not minimum. What am I thinking? Okay, you know what? Ignore that. So you have k swaps, right? The maximum number of things that can be out of place using k swaps is 2k. Why is that? Every time we take two different unused indices and we swap them, and that puts 2 of them out of place. So yeah, so the maximum number of things that can be out of place is 2k. So that means that the minimum number of things that have to be in place are n minus 2k. Now, luckily for us, that the number of swaps, m, is less than or equal to n over 3. So we have to have at least this many things in place. And since k is less than or equal to n over 3, and this is greater than or equal to n over 3. So what that means that you need to have at least n over 3 numbers in their correct spot for that to be a valid cyclic permutation. So for example here, this one has 2 numbers in their correct spot. Since 2 is greater than or equal to 4 over 3, then we need to check this. This permutation has 0 in their correct spot, so we don't need to check this. We don't need to check this. We don't need to check this. This only has 1 number in their correct spot, and 1 is less than n over 3, so that's why we don't need to check this. So we can calculate the number of things that will be in their correct spot for each of 0 through n minus 1 for each different shift. We can calculate the number that'll be in their correct spot using this sort of idea. So we can think of it like starting at the 0th permutation, 1 will be in its correct spot if you shift it by 2, right? So that means that let's make a table. 1 will be in its correct spot if you shift it by 2. 2 will be in its correct spot if you shift it by 1, 2, 3. 3 will be in its correct spot if you shift it by 1, 2, 3. 4 will be in the correct spot. It's already in the right spot. So the frequency count of the values of this table just forms the number that will be in their correct spot. So like the frequency count of 3 is 2, that's why 2 are in their correct spot here. The frequency count of 2 is 1, that's why 1 is in their correct spot over here. And 1 is in the correct spot over here, because the frequency count of 0 is 1. And then the frequency count of 1 in this table is 0. That's why 0 are in the correct spot. So since the frequency counts sum to n, there will be at most 3 different shifts that you have to check. So in this case, there's only 1 shift. You only have to check 3. But there will be at most 3 different shifts you have to check. And you can check that using brute force. So let's say you have some shift. So 2, 3, 4, 1. Let's just use this shift. Okay. So the desired array is 2, 3. Wait, what is the desired array? This is the desired array. The array we have. The array we have is 2, 3, 1, 4. So we can check if it's possible to get this from this by using a DFS. So what I mean is that let's say we create a graph with the indices that are not in their correct spot. So, or with the numbers that are not in their correct spot. So 1 corresponds to 4 here. So we can like connect an edge here. 4 corresponds to 1 here. We connect the edge here. So the number of cycles, the number of swaps it will take to fix this, fix some permutation, is the number of things not in their correct spot minus the number of cycles. So the way to see that is for each cycle, the minimum number of ways to fix it is the size of the cycle minus 1. So you need that many swaps to fix a cycle, and let's just say it's more complicated here. 5, 6, 7. So then you have another cycle here. So yeah, to fix a cycle, every swap takes one element out of the cycle until you have 2. And then one swap will fix both of them. So if each cycle it takes cycle minus 1 number, the size of the cycle minus 1 number of swaps to fix it, then it's the sum over cycles of size minus 1. We can break this up, and the sum of the cycle sizes is obviously just n, or like everything that's in the graph. So that would be the number not in their correct spot, and then minus 1 for each cycle, so minus the number of cycles. So if this number is less than or equal to m, if we can do it within m swaps, then we're good. So we can just brute force that using a BFS to calculate the number of cycles. And yeah, remember we only had to check at most 3 indices, so that's why it will run in time. So yeah, those are solutions for A through E. Hopefully I don't get hacked or anything. People are getting screwed over on D. What's the deal with that? Oh my god. You messed up D too? I mean B. Wait, how far is the Q? Wow, I actually got a hack this. That's my first hack ever in the Codeforces round. Alright, yeah. I guess I'll end the recording here. Thank you for watching. I think I have like plus 10 delta. It's not terrible, but E could have gone way better. But yeah, thank you for watching. Did it stop? I think it's lagging.